Hello and welcome to the second half of our IoT week. Today is day 4, the Maker Day. And I'm Daniel Ho here at the headquarters of Microchip with Clifford Swartz. How are you doing, Clifford?
I'm doing very good. How are you, Daniel?
Good, good.
So, like you said, today is Maker Day, and we would be remiss if we had Maker Day without having the Wizard of Make himself on Skype with us right now. How you doing, Bob?
Hey, Bob.
I'm doing great.
And in addition to Bob, we have Kathy Giori, who is an IoT industry advisor and EdTech entrepreneur. You guys excited? You guys ready?
Yeah, we are ready to go.
Yeah.
We are ready to go. So,
we also have some guests from the booth.
Yes, we're going to throw it back to our booth.
Hey guys, how's it going?
Hey everyone.
I can't believe it's day 4 already of IoT week. It's been an amazing week. I think my favorite day has been home automation. Welcome, Ross.
Thank you.
First live stream.
It is.
Yeah,
it is.
awesome.
Very excited about today.
Yeah, so for those if you missed some of the topics this week, just check out YouTube and watch the replay. A lot of the interesting topics this week on IoT. But to get back to the live stream, we are going to do a survey at the end. We're going to pick out winners. We're going to be giving out Arduino Nano 33 IoT board and then a SAM D21 Curiosity Nano board.
Nice.
So that'll be exciting. So just stay tuned in the chat. Ross will be putting out a survey link at the end, and we'll pick out winners after. So
Cool.
Be fun. Yeah, we're ready for this. We're ready for the wizard to take over.
Wow, so excited
All
for
right.
the free samples. Let's,
all right.
Let's roll to
All right.
Bob.
Yeah.
All right. Thank you, everybody. And again, Maker Day. And with me here in San Jose is a good friend of mine, Kathy Giori, who's been an advocate in the open source community. She's very heavily involved in the OpenWRT project and all things open source. She used to work at Arduino as well. And I'm kind of excited now because what we're going to be talking about today is moving the cloud into your terms with a concept called WebThings, which is an open initiative started by Mozilla. And again, she'll go into further detail, but the concept is now with obviously some of the concerns like Alexa or Siri devices that are listening to you, well, there is another more maker-friendly solution. And with that, I'll pass it over to Kathy.
Thanks, Bob. And I will say that I will be highlighting some projects where Bob has been a hardware designer as we go into the making of things. So just to lay out what we're going to cover today, there's some projects, open source projects that I'm engaged with right now. One, I recently was working on the IoT project at Mozilla. I'm heavily involved with the project at Microblocks. We're going to be demonstrating that today. And some of the deeper engineering, I'm just going to show off very briefly Platform I/O, which is my way of doing the deeper dives into the hardware. So the first thing I'd like to do is give you a quick overview of these things through a slide deck, but don't fear. The slide deck is just to give you a taste of what's going to happen, and then we're going to go into the hands-on session. So if you guys could pull up my screen, there we go. And as Bob mentioned, the coolest thing we did over at Mozilla was instead of sending all your smart home data to the cloud, why not process it locally? I mean, there's really a whole ton of processing power on these small Raspberry Pis and other embedded Linux devices. So what we're going to show you today is an IoT forecast that's sunny and clear, no clouds. A bunch of links on this page, and I'm going to highlight a few projects. So first I wanted just to banter with you a bit, Bob, on physical computing. So your guess, the most incredible class of physical computers is?
The most incredible class of physical computers? Well, there's that's an open-ended question. So,
my answer is human beings.
Ah,
I think we are the most incredible class of physical computers because we have all these senses, our 5 senses. We see and we hear and we taste and smell, blah, blah, blah. And not only that, we have these brains that are like processors. They're intelligent. They're not artificial intelligence. They're intelligent. And so when I think of physical computing, I make analogies to us as humans. In the technical world, we have cameras, we have microphones, we have accelerometers, temperature gauges, particle, smoke, and leak detectors, right? Those are all sort of analogous to our senses of our human being. And then on the actuation side, you know, an on-off switch is like my eyelid opening and closing. Our lungs are pumps, you know, our bodies regulate temperature at like a thermostat. There's all sorts of analogies you can make. So what physical computing is really cool is that you get to make things out of technology, and everyone as a human being can kind of relate to what you're doing here.
Right.
We're just introducing microcontrollers and processors and sensors and actuators instead of our own beings. So these things act as our remote eyes, ears, arms, blah, blah, blah. But instead of creating a whole human being, which is, you know, takes 9 months and is hard, I can attest, we're going to sort of do purpose-built things. So one of the coolest things, I think, for intuition of understanding physical computing is this project called Microblocks that this year should go into its 1.0 release in a couple months. But it's just an excellent tool for understanding the physical computing without getting bogged down in syntax errors and programming languages and other kinds of things. So there is some high-level lifting under the scenes that has to get you to this level, but once you get there, it's pretty fun. And it supports several common boards, the BBC Microbit, Circuit Playground Express, several of these expressive modules. And there's open curriculum shared for education. You know, its software is open source, free to use, translatable to any languages, both the source and the curriculum. So I'm just super excited about Microblocks as a tool for education.
I'll just well, let you go into Platform.io, which is another. So for those of you who are out there that are familiar with Scratch, this is a persistent version of Scratch, and it's really useful in the education space because it lets the students see the flow. And we are, well,
so I'll demonstrate that later.
Right.
The liveness is really allows you to understand the physics without having to wait to download your code. You know, it's pretty cool. And the reason that happens is there's actually the heavy lifting is with Arduino scripting that I run. There's a virtual machine project where all these different platforms are described in a Platform.io ini file, and I can just pick a board, mention the environment, and it will build this virtual machine for me and download it to the board. Once I have the VM, then I just plug it into the Microblocks IDE, and everything is live thereafter. So what's really going on under the scenes is there's this byte code that's being processed, just like opcodes, under the scenes. And when you unplug the board, those blocks that you see visually on your screen are actually already in bytecode on the microcontroller. So you plug it back in power, they continue to run. And as I said, these activity cards allow teachers not to have to be experts before they do this, because one of the big problems is, like, when do teachers have a chance to understand this stuff before they move on? So we have all these activity cards that help. Basically, you can just throw them at your students and they can get going.
Right.
So rather than show these video feeds, I put a little link to YouTube where I've posted some of these videos, and the Circuit Playground Express I'll be demonstrating today is just full of bells and whistles. Super fun board to do. Now that's on the thing side, and now I'm going to jump over to what we talked about on the web of things side, which is these IoT devices. You know, how do I make my push button able to control your light turning on and off? And what I did at Mozilla was I was on the IoT project called WebThings, and we took the W3C specification for the Web of Things, which has all of these different protocols and APIs. Why don't we bridge the interoperability rather than at the radio or the protocol level? Let's just bridge things at the web, where web services are already popularly used. So
I just want to jump here again. I know people, I'm seeing some comments, and I can see that the resolution of Kathy's slides, I know, is not optimal for everybody. We will get a link and publish a link
I can share
so you can get the slides. she's sourcing from a MacBook, so I don't know. That's the Retina display. Some leftovers.
Yeah, you don't
anyway,
have to read all the text.
You don't have to read. Yeah, so don't everybody that's on there. Don't worry. These slides will be presented in crystal clear HD stereo, like on a link. So.
So, Bob, do you have any concerns about smart home privacy, security, interoperability?
Yeah, absolutely. And
what concerns might you have?
One of my so I have twin daughters, and as a present last year when she scored straight A's, I'm very proud of her. Her present was, okay, we're going to get you finally a flat screen TV in your room, and Amazon Fire Stick.
Smart TV.
Yeah, smart TV. So I know enough that the smart TVs, especially the Samsungs, will almost every smart TV now, they have microphones. They're listening to you. Okay, and again, when you buy a Fire Stick now, the remote controls have Alexa microphones built into the remote controls, and there is no way to shut that remote control off.
Ooh.
But there is a way.
I didn't know.
So on iFixit, they actually had a method where you can pry the remote apart and get at the microphone.
Okay.
I think Amazon was paying attention to that iFixit article and changed the way the remotes are sonically sealed. So the next solution is you take a drill with a 7/64" bit and you just drill out the microphone, and then I filled in the hole with some 5-minute epoxy. So Amazon has no place in my daughter's bedroom.
Well, so it's not. I would say the creepiest things are the microphones, and then especially the cameras.
Yeah.
So cameras also, because they are beefier devices, I'm happy to see more industry at least moving toward two-factor authentication as being a requirement, and then the secondary thing would be like, would they allow you to disconnect them from the internet? Because in our paradigm here that we're showing off today, everything connects locally, and it's only you that tunnel in remotely to see your stuff. So let's jump over there. This slide, hopefully you can see it a little bit. It just shows that on the left, you've got no data that you're sending to the cloud. You're basically storing and processing it all locally in your home. Your home is your data center. And then you tunnel in. I can do it with my cell phone. I can do it with my laptop, anything that has a browser. All you need is a browser to tunnel in over HTTPS to get at your data, to remotely control things or remotely monitor things. Whereas today's industry approach, the typical vendor is, you have an app for every single brand you buy, and you connect up to the cloud to see all of your data when you're outside. But that lends to all these security and privacy implications. Not to mention the lack of interoperability between different vendors.
Right.
So the private smart home approach we're showing today is we're running a gateway. Again, I'm running it on Raspberry Pi 4. It sits in your home. I run my own smart home this way. You can buy smart devices from the store because there's an add-on framework that lets you bridge those protocols and those things to this WebThing API. And you can make your own. So I'm going to show today how we're going to make some of our own. And the ultimate value there is consumer privacy.
Right.
You can manage all this through a browser, any browser.
And again, I want to work if you've got, smart lights from one vendor and smart
buttons from
another vendor. This all brings it into a homogeneous web presence, and that's through the gateway, right? And again, the gateway now is basically there is a ready-to-go image downloadable from Mozilla that you just download. It's a full Linux Debian based. Raspbian.
We have a Raspbian image that you can download, put on the SD card, and put it inside Raspbian. We have a Docker image.
Okay.
And then we have packages now for some of the popular distributions.
Okay. So essentially, the cost of entry for this system right now is an RPi. 3+, I've used on 3+. That's a 4, but we'll show off anyway.
So the photo on my screen now just shows it's probably there's probably even more on there, but it shows that everything shows up then as an icon on my desk, and there's a little detail that I'll show you a little later. But basically, I can command and control things and set up rules, which is really fun and flexible to do all these things. And then you'll notice there's a little speaker microphone plugged into. There's two things plugged into my Raspberry Pi's USB ports. One is a speaker microphone, and one is a Zigbee dongle. So I tend to use a lot of like the IKEA Zigbee stuff and the Samsung SmartThings Zigbee stuff. I have some Xiaomi stuff, and they pull all together, and then they're all interoperable at the web layer. And that speaker microphone is actually used for private voice control, which I'll demonstrate here today as well. So let me show you how simple a web thing can be in terms of definition with microblocks. So microblocks got a Mozilla open source support grant last year to stabilize, finalize the Web of Things library. So there's a Web Things library that has Wi-Fi connection for boards that you can do Wi-Fi, such as this SAMW25.
Right.
This guy right here. There's then you define the type of thing, because there's a list of standard capabilities of things, and then you add properties. They can be Boolean properties, they can be level, multivariable properties, or they can be events. They haven't added actions yet to the microblocks library for web things, but essentially I mostly use properties. So I define a light. I can turn on and off an LED. I define as a capability light, and I give it one variable called on, and basically you're good to go. I can test it in the IDE, and I can just forever set that variable, which is defined in the web browser and mimicked on the actual physical hardware. So this, again, useful links. Maybe the type font is a little bit small here, but microblocks.fun. The IoT project is at iotmozilla.org/gateway to get the downloads. All of it that I'm talking about today is open source, so the open source for the GitHub Mozilla IoT, and from microblocks.fun there's a link to the source. Their source is on Bitbucket, and my GitHub account is a little out of date of examples, but I hope to update that soon. And now we're going to jump into demos.
Excellent. Okay. And again, I just want to reiterate that slide deck will be available off the link in any and all in all things. It's not your eyesight that's going. It's
yeah. Okay, so my screen still shows the Platform I/O tool, so I just wanted to quickly remind everyone that something like this SAMW25 is described in my Platform I/O ini file. So you can see the last thing that I flashed was an itsy bitsy for this Neopixel here.
So I'm just going to jump in here again, and for those of you, Platform I/O, what's on Kathy's screen? Platform I/O is a development backend for Visual Studio Code. Okay, and it's another alternative if you're looking for, again, Visual Studio Code cross-platform. Platform I/O, think of it as a snap-in backend that gets you about to the same place as MPLabX or Atmel Studio. Again, Kathy and I know Ivan Kravets, who is the creator of Platform I/O, and he's really good to work with because he's adding boards, microchip boards, to SAMW25. I helped him bring in the SAMW25. For those of you looking for another alternative, and I'm not trying to steer you away from our development environments, but essentially, if you're a Visual Studio Code lover, Platform I/O is a good thing to look at, and I'm sure.
And if you use multiple boards.
And if you,
in this case, I'm just going to do PIO run for the environment SAMW25, and then it's just going to compile for this board, and it's going to tell me it's successful or not. I upload to the board. So I just wanted to remind everyone that this is just one project that you can clone the Bitbucket clone and git clone, and then I could, at any time I can git pull, and I'll always have. So you see that successful compile for the SAMW. Git pull, I'm already up to date. So I just use this as my means to manage these boards. And when I have a board working in microblocks, when I plug this in, if you can see my screen now, hopefully it's big enough, there's a little USB port thing on the top that turns green when it's active. And the very first thing you tend to do is say, set user LED. And I don't know if you can see in the screen, but that LED turns on and I can change it and the LED turns off again. And there's actually a button on here. So let's see, button A. If I'm not pressing button A and it's false, and if I do press button A, I got to make sure not to test the reset. Now it's true. So I'm going to unplug this board because this board doesn't have a lot going on without me plugging in an extender. And I'm going to jump over to the Neopixel, which is a Bob designed board. You want to talk about this while I plug this in?
Yeah, the Neopixel is a board we designed for another project, and it's got what Kathy's showing up is that's actually an Adafruit Itsy Bitsy Express.
M0.
It's a Cortex M0 Plus, SAMD21 sitting on there. For those of you who tuned in on Tuesday, where we had Laura and Philip, that board runs CircuitPython, and we've also
it's got a dot star on the back.
It's got a dot star, so that's a Neopixel, and there's 7 Neopixels on the front, but it just makes a very colorful UBI thing that shows the interaction of microblocks together with the WebThings, because right now it just looks like, well, she's just got it hooked up to the USB on her Mac. But apparently, well, not apparently, but what she's going to basically show is how easy this is going to be to move from the microblocks that she's putting together now, which is a local instantiation, to bring in the WebThings interface on top of that. So it goes from local control down to the web control through the web gateway. Okay, and it's going to be literally seamless.
But right now, the first thing I did was I demonstrated Arduino Blink, basically, with a half-second delay, but set the user LED on, wait a half a second, set it off, and just I click start and it goes. And if I click stop, then it stops. And so now, this is the cool part of this board is actually the front side, which has 7 Neopixels on it. So the next thing, I'll let you hold that up.
Okay.
And I'm going to throw out this program, and I'm going to show you, if you look at my screen, there's these libraries I talked about. One library I'm going to need is the Neopixel library, and another library I'm going to need is the WebThing library. And so what I'm going to show first is the Neopixels. I'm going to attach 7 Neopixels, because that's what there is on there. And I happen to know that they're attached to pin 5 of the Itsy Bitsy. And once I set that and click that block and then make that definition, then I can, actually, I'm not going to brag, and then I can set all the Neopixels to green. I can set them all to pink.
Wow.
I can set them, I can just change the colors out. I can clear the Neopixels. And so now I'm going to build a little program really quickly. I'm going to say, when I get started, attach these pixels and set them all to the color pink, and then maybe, actually, yeah, and then wait half a second, and then I'm going to copy this block and set them all to blue.
And then I'm just going to jump here again. Sorry, Kathy. It's like I realize that the color saturation, much like anybody who's seen the YouTube videos on that paint color called the pinkest pink, getting contrast, a good contrast out of webcams is tough with LEDs, because otherwise Kathy and I have to sit into a dark room and then the color oversaturates. But,
So now I'm going to talk about how to create a web thing. The way to now I want to remotely through my browser, turn these Neopixels on and off. We're
Right,
going to do
so-
a very basic thing.
So here
all
comes
I'm
the
going to do
non-cloud.
is say I need a variable. I'm going to call it on, and I'm going to set this variable right off the bat to true. So if you look, and I'm clicking on the left side navigation, and under math, I have some Boolean stuff such as set on to the value true, attach my Neopixels, set them all to pink for starters. We can hold on to one of these blocks. I won't need that wait block. And then we move over to the WebThing library and we say, okay, I want to define this thing as, let's call it Snowpixel. And it's going to be a light. You can see there's a whole drop down here of lights and multi-level switch, all these web things that you can define. And then I'm just going to add a Boolean property using that on variable, and it's of type on-off property. And again, these are motion properties, leak, doors, and whatever property you pick, the web GUI will actually show the type of property it is. And then, so now I have my web things defined with just a light with an on property. And the last thing I'm going to do is set up my control. And I'm forever going to, if the on variable is set, we are going to turn all the Neopixels to blue, else, oops, I didn't mean to actually click that, else we're going to clear the Neopixels.
So it's almost like building like a Lego.
Yeah, it's kind of eerie. It takes, like for someone like Kathy's very, very astute at microblocks. For me, I'm fighting 25 years of C programming overhead.
That's gonna be a hard change for you.
It is. It's just the paradigms. And I saw a question come up in the chat. Is there an option to use Python or C? Yeah.
Oh, sure.
Yeah, absolutely. You're not restricted to using microblocks.
That's a good point. IoT.mozilla.org/framework has Python, JavaScript, C, I mean, basically any language.
Right.
Any language that you can produce JSON. So what I should have showed you, or I could still show you, is the output of these WebThing blocks is basically a JSON description.
Right.
So whether you publish that JSON using Arduino code, MicroPython, CircuitPython, JavaScript, doesn't matter. You're publishing this JSON, and that's actually what's going to be read by the gateway.
Right.
So right now I have my script. I'm going to say when started. It's going to show up. It's turned on, and then I'm going to say and set the on variable. So right now that I turned it off, every time I click this test block, it goes on and off and sets the color to on or off.
Okay.
So now all I need to do is I could pull it over to my gateway and plug it in, and that's going to be the next step. Before we do that, this one is a little boring. So I'm going to show you what the students did with this Snowpixel, and I'm going to pull up an example instead. I'm just going to open it. I already had it stored. We do this for the last couple of years, Christmas in the Park in San Jose. And this particular project defines how you can create your own blocks. So we took 15 examples from students, 15 patterns that the students had made, and rotated them through. We created a web thing that had a pattern number that you could set, or you could send it to random patterns or not. So I'm just going to start and run this block and show you how basically it says if pattern is 1, run the snowman. If pattern is 2, run the multicolor patterns. And all these patterns were set up by the students. So now how this works is all I have to do is unplug it. And this is where the My Blocks comes in over here. All these different patterns were things that the students had created. So I'm just going to plug this into my Raspberry Pi gateway.
So I think we should probably switch over to.
Not yet.
Not yet. Okay. Not yet.
I'm gonna pull it up on my screen. Okay. So actually, we can still show it here with.
Okay. I swear that this board is no longer plugged into
Not
not
plugged into
her
my
not her
laptop
MacBook.
anymore.
It's plugged into
Okay, so
an RPi we've got sitting over, and we'll get an overhead shot of it where
this
she's got all
one
sorts
is
of
not the one I
cool
want.
toys.
Let's see this one.
But
Okay, let's see. No, that's not the one I want either. Maybe it's on this one. Yeah, here we go. Okay, so this is the Raspberry Pi that is sitting on the desk that you don't see the Pi yet, but we'll show that to you in a moment. There's already a Circuit Playground Express called the Rainbow that I plugged in. That was a device that created a web thing. What's going to happen on this Things page is I'm going to click the plus button, and I'm going to look for this thing I just called the pattern pixel. I'm going to save it, and now that it's saved, you see that it's running. I'm going to just turn off the pattern pixel by clicking the user LED. Now the patterns have a certain amount of time, so they don't immediately stop unless there is actually a stop task thing, but they basically finish off the last pattern, and then you can see in here we're set to random patterns. So if I turn it on again, it does pattern 14, and now it's doing pattern 2, and it can switch to different patterns. I happen to know by heart that pattern 13 is like this static rainbow. So I'm going to turn off the random, and then I could actually type in, pattern 13, and hopefully it would. Whoops.
and let's just make sure that everybody understands what we just did in the past minute. We pulled up Lego-like code and downloaded it, and gave this Snowpixel, which could be your garage door opener, a name. And what's on Kathy's laptop right now, that is the web page being served up by the WebThings server off the Raspberry Pi. We went and looked for it, and it hooked it up. Yeah. And the WebThings, all the properties of that whole microblock support, which happens again, which you can get in Python or C, gets transmitted again through the magic of JSON to this WebThings server, and we just basically point and click a brand new device.
3 properties: a Boolean on-off property, a variable pattern property, and another Boolean random property. And now the beauty of this voice controller is I can, I'll just demonstrate first. Hey Snips, turn off this pattern pixel. And you see, I even stumbled in my words of remembering what the thing was called, but pattern pixel was not known until I plugged it in, and we dynamically updated this small language model to be able to set that. And I can say, and now I just want to show you rules. So I have a rule already. Actually, I'm going to drag this pattern pixel over to.
Okay, and that voice recognition, again, local. Her voice did not go farther than my Verizon hotspot that all this is hooked up to.
It's just
not in the cloud.
It did not.
All
it's
processable.
local.
So I'm creating a local rule. I have one, just a 1-second pulse. It's actually a virtual thing called Things, and when I say turn on the Things, I turned on the rainbow. I'm going to add now the pattern pixel. So now when I turn things on, I'm going to turn them both on. And similarly, I have this rule of everything turned off.
Okay.
I'm going to turn them both off. So now I could use my voice or the button to turn things on or off. So for example, they're both on, and I can say, hey Snips, turn everything off. And everything turns off. And I'll just show you what's happening behind the scenes is in the event log you can see. And note that I'm saying a wake word called Snips. We're currently using Snips libraries because Snips had open source libraries to create this add-on. I'm working closely with the deep speech team at Mozilla. Since Snip was acquired by Sonos, they're no longer keeping their source code open source. So we're having to move to, and we needed that time anyway. Deep speech is now only just in the last few months able to run on this Raspberry Pi 4 locally without needing the cloud. So let's just try this one more time. Hey Snips, turn things on. And so you see it detected my wake word, data detected as turn things on, and then there's what's called an intent parser behind the scenes that matches it to what's going on here. So I just wanted to show you a couple more things. You can set this down now,
Okay,
Bob.
all right.
Thank you. I'm gonna put that into the picture view for later,
Yeah.
So
but
I
I'm
do
gonna show
have
you
a
a couple.
question for this.
Sure.
Just out of my curiosity, like what I need to do to get this whole thing set up. Do I need to set up my own server?
No, you just, so I put the link in there before, but on iot.mozilla.org, there's this gateway page where it says learn more. And you can decide to run it on a Raspberry Pi, and you just download and flash to an SD card. You can download and run it in a Docker container on a Pi or any other embedded Linux or just Linux laptop or anything.
So I just follow
Docker here.
the web page. I set up my own Lego blocks, and I'm good to go.
Right.
Yep.
And there's the Getting Started guide for the Raspberry Pi just shows, once you flash your SD card, you plug it in, you connect it to your local Wi-Fi it acts as an access point. You give it a subdomain, and this is the important part. This allows you to tunnel in only over HTTPS, and you give it a first user account. And now you're the only one that can log in, and you end up at the WebThings page.
So yeah,
that's great.
Yeah, exactly. So yeah, it's basically the cost of entry is, like I said, I've got a server set up at home. I've just been lazy and not. I don't have like lots of little things around, but I've got like a server running. And there was a question, essentially what protocol? It's JSON over HTTPS.
Yeah, so once it gets to and I'm going to show you what they add on. So for example, this weather input, when I click the detail on weather, the weather, I've put in a latitude, longitude of Stanford, and it shows me the weather. This is actually data coming from the internet, where I filter it to my own personal, what I care about, rather than going to all these sites to see weather data and to see UV index data or to see whatever. I can just pull it into me at my location, and that's what's important to me. There's a date time thing. And so I'm going to show you, I'm going to slip over to my house as well to show you a little bit more details. This one is just set up for this demo, but basically I'm bringing data in, and I could say, based on if it's raining or not, turn on my sprinklers or not.
Okay. All right.
So it is an IoT under the roof.
This is a smart home automation system where you can mix and match things you make with things you buy. So how do you know what's supported? Under settings, there's this add-on framework. And this is where the beauty of open source comes in, because the community has contributed a lot of these add-ons, more than Mozilla had built. So I have earthquake monitor, don't have it enabled, but it's kind of fun. It pulls USGS data. This pulse adapter is what I used to have the 1 second things and everything pulses that I can assign to rules. The voice control, this one was built by Mozilla. And then all of these, you can click the link by, and it shows who built it. So by Philippe Koval, who used to be at Samsung's open source group. You can click on any of the names here, and it takes you to the GitHub account of the add-on.
Okay.
At home, I use this fun add-on for Google Home, which I actually have a Google Home, but it's left on mute. But I use it to make announcements, and that's pretty fun.
Okay.
And so you can set those things up.
So just going back to a question we got coming up on voice recognition. What's the minimum? I think for voice recognition, I mean, the RPi is doing it. That's an RPi 4. It works on an RPi 3 plus.
Yeah, so the SNPs libraries work on a 3 and a 4.
Okay.
And so far they've been testing deep speech on a 4, and I don't know if it's ready for a 3 yet. There's some latency issues that you don't want latency, but it'll definitely work. It's definitely been proven to work on a 4 so far.
Okay, so I guess moving forward with deep speech, look for a 4 or 3 plus, but
or use the existing add-on with a 3.
Right, or use the existing add-on with a 3. Plus, I mean, if you're going on to a Docker container or like a native Linux image built, they had then
if you have
it's a non-issue. Like
laptop or anything else, you're fine.
Go to a hardware refurb and pick up a $30.
Just
laptop.
Use old laptops.
Yeah,
Who
use
doesn't
old
have
laptops.
I got a couple old laptops.
Just throw in
Another
laptop.
good add-on is this OnVIF camera thing. So you can actually stream or snapshots the OnVIF protocol through to your gateway.
Okay.
And again, there's some that, and then what I didn't mention also is a bunch of notification add-ons. So for example, Prowl, this is something, I don't know, I haven't used it, push button or push over, push safer. I just use Slack. There's actually, if I scroll all the way down there, I just send messages to one of my Slack accounts and I direct message it to me. And so now when like if there's a leak under the sink or something else is intrusion detection or something, I send, and then I get the messages. I have notifications turned on for that particular channel so that it interrupts me, like something's. I use the Sonos add-on, so I have private command and control of my Sonos speaker without, you know, any cloud.
Okay, so why don't we let's go look at the toys on the desk, which is. Yeah. So as we're switching over, she needs to switch over.
Just before I switch, one more thing that's easier, that unfortunately the user interface or the screen on the Raspberry Pi on the desk is a little small. I just want to switch over to my house and show you quickly, like snapshot. This is coming from a camera. There's all of the like Samsung SmartThings buttons. They have temperature and things like that. And so the cool thing about that is I just want to show you the logs and the floor plan. So I can see when the entry door was opened, you know, when I left the house, you can see the motion in different places of your house. You can see that the front door wasn't used for a couple days. We always go through a side door. I can monitor the temperature on this button. I have a little temp sensor. And then I have temp that I pull in from the weather. So you can see this is every 60 minutes coming in from the outside and then comparing it to my inside temperature. I also monitor the earthquakes, so I can look back and see what was the height and then the distance from my house, so it's specific to me. And then there's other motion sensors. And then I also row in the bay, so the tide in Redwood City. All these cool things that you can tie together in one place. And there's also a floor plan view, so I can turn things on. This is like a house rule button where I turned a bunch of stuff on, and I'm kind of freaking out my house guest right now, but so I'll turn it back off. But you know, it's pretty fun. And,
yeah. So Kathy's house is essentially alive.
That's a live environment right there.
Yeah.
And so now we're going to go back to, remember we made these things. So we added the pattern pixel and we already had the rainbow. And so now what I think we're going to do is we're going to add one more. Oh, I want to show you one more thing in Microblocks, and then I'll plug this last one in before we go over to that display. And I also want to explain that because this is a web browser based, you can pull it up on your smartphone. You don't need to carry around a laptop to command and control things. So the rain patterns and the things that are sitting over here, I can control those with my smartphone and turn them on and off. Okay, so one more thing I wanted to show you is a couple of examples using the Circuit Playground. This is one of my favorite little boards. This one I have it in a little case. But I'm going to show you, for example, you could create your own motion detector by just using the accelerometer on board here. So I define a motion sensor with a Boolean property of whether there's motion or not. And if I run this, it's now, and then I'm going to do something clever, which is I'm going to graph it. So when there is motion, it's going to be bright blue, and when there isn't motion, there's light blue. And I did forever graph this motion, and now I just want to show you one of the beautiful things about Microblocks is this is live, right? I can see, if I click it hard, so I can see the data, and then that allows me to say, okay, I'm seeing the data, like if there's motion over level 25, then I'm going to say that motion is detected, and I'm going to leave it on for 2 seconds, and then and then if it stays on. So if I shake it continuously and it's always over 25, it's just going to stay lit. So that's one of the very cool things about microblocks is you can save variables, you can plot variables, and I can turn this into a web thing. And when I turn it into a web thing, it shows me the little person icon, and it illuminates it when there is motion. Okay. So now rather than which was I? Oh, another cool thing. How much time do we have?
I would say let's give it about 10 minutes because we have to run a survey.
Okay.
So.
Because the other cool thing, maybe I don't have time to demonstrate it, but this little IR transmitter, this has an IR receiver on it. So you just go into the libraries and IR remote, and you click OK, and it happens to be on pin 11. So there's an attach IR receiver to pin 11, and you can receive the IR code. And so I could just say IR code. And so if I put that together, so now you could do remote control things. So I just push the number 1, and it's remote control, and then I push this again. And it tells me the code of each of these little keypads. So I can remotely, use these cheap little remotes to turn things on and off in my house, which I think is very useful.
So again, that just to summarize what's going on is she just, in the order of a couple clicks, the Circuit Express Playground again is a really popular board from Adafruit. It's natively supported both in the microblocks and the WebThings, and that remote control is a very generic remote control, again available from Adafruit or SparkFun. Okay, no custom remote. Just to reiterate the completely agnostic nature of platforms and controls.
And so I wrote this little script that says this also has a tone, has a piezo that says when I push the button, play the notes. So I'm going to push 0, 1, 2, 3, and you'll hear the notes.
Nice.
There we go.
So I said, code 48, whatever, play that note. So you can create all sorts of fun things.
So I really want to get over to what's on the desk.
The last thing,
and then
load.
Then we're done.
Okay.
And so there's a couple things I've noticed that I want to make sure people are clear on is, again, apologize again for the video quality coming off of Kathy's video. We're going to redo this, like not live, but we'll walk through this coming off of my laptop or a PC laptop, or just figure out what the resolution issue is, because I for those of you who are sitting there, out in WebStream land, this has been like a ton of information that maybe you weren't aware of. Like there's just a lot of stuff going on here. Okay, we've got WebThings, we've got a server, the WebThings server pushing a web page off the RPi, which is sitting just over to the right of Kathy, and let's.
Okay, so now we're going to switch to, I just added the one last thing, which as I called it an alarm, and we're going to switch the video feed, bear with me here, and do the down camera.
Okay, so this is all the magic stuff.
All the tricks.
All the tricks. So that little LCD screen, that's actually
a touch screen.
A touch screen hooked up to an RPi 4 in the back, and these are all manner of. So the actually, can you move your Circuit Playground Express so it's in the camera shot? Okay, that's the Circuit Playground Express that we just added.
We just added as an alarm.
Okay.
And so it shows up. I'm going to actually move it with my other screen. I'm going to show it next to the pattern pixel. So now the alarm shows up here, and see what happens when the alarm goes off. So now I could do things like, if a door opens, if a motion sensor goes off, I can define a rule that sets them on. So for example, I could just say if the pattern pixel is on, turn on the alarm. I'm setting this rule up.
So she's setting the rule up. You can't see, but on her screen, she's interacting through a web page with the same server that's pushing the web page up on the Raspberry Pi. Okay, that's the connection.
So now if I turn on the pattern pixel, the alarm goes off, or the alarm goes on. And what I should have done with that rule, which I didn't, I said if it goes off, turn on the alarm, but I'm going to actually change it to a while. So you can do while the pattern picture is on, then do the other one. So that's even easier. Now when that one is on, oops, and that one goes off and it comes back off again.
Okay. And then you just want to demonstrate the voice.
Yeah, so now we just turned, the alarm is actually a settable thing, so I can say, hey Snips, turn on the alarm. And then I can turn it off.
Nice.
So you can see that all of these things get picked up. I still have my things button, and that's now going to trigger that other thing, turn everything off, and voila.
All right.
It all works.
Okay, so again, a wall of stuff. And I think
super fun though.
a wall of stuff. I think is probably, again, we'll clean up the resolutions, and I think if we get enough feedback, I'm going to throw it out there. We're dropping a survey out right now, but for those of you who have just watched this wonderful lights and colors and sound stuff, I think that we are willing, more than willing to break this down over more sessions or YouTube videos or whatever. I think.
And you can reach out to me if you do when you do get the slides. Contact me if you're interested in the education angle. If you're interested in IoT for commercial, I still think this has a lot of value, and I would like to see companies. I would like to help companies do smart home automation or smart building automation or smart anything with privacy in mind.
Right.
I mean, open source and privacy.
So the key thing here is the privacy that you control. Again, I'm going to pound this in over and over again. You control what comes in and what goes out, right? That voice, again, you yelling at your dog in the living room does not leave the gateway. Okay, so minimum right now, voice processing, an R4 right now with deep speech, because again, once that comes in, the speech is going to be a lot. I mean, it's good right now.
Yeah, we're going to have a workshop at IoT Fuse in April if the event isn't canceled with the RPi 4 and the deep speech stuff.
Okay, cool. All right. Thank you so much.
Cool.
Thank you so much.
Oh, we're not supposed to do that. Wait.
Oh, no. Oh, no. Oh, man.
Elbow bump.
Okay, you didn't see that.
Virtual elbow bump.
We're going to have to do that. All right.
Sorry.
Well, cool. So as Bob said,
bad habits, yeah.
So as Bob said, we dropped a survey link in the chat, and for those people who filled out the survey yesterday, if you were one of the receivers of the boards, you have received an email. So make sure to get back to us with your name and address, and we'll do our best to get back to you.
Yeah, I'm excited.
Yeah, very much so.
Yeah.
We're going to take it back to the booth for some final goodbyes and any last programming notes.
Hey guys, well thanks Bob, thanks Kathy, it was great. The alarm definitely woke us up back here in the studio.
Who needs coffee when you have that alarm?
You're not supposed to say that. You guys said you guys were on point.
It was on point.
You
absolutely.
were on point, right on point.
Yeah.
Woke me up, right on point.
Yeah.
But yeah, like Bob said, we'll be sending out the slides. I want to thank Ross for helping out today. Good
Thanks
job
for
on
having
your
me.
first live stream.
Yeah, good work.
Elbow bumps. Yeah,
we
thanks
go.
everybody. Again, the survey is out on the chat, so fill it out. We'll be emailing the winners. And if you won, please reply back so we can know where to ship your board to. As well as check out the YouTube on our channel for previous events that happen throughout the week. And I want to thank everybody that's watching, and see you guys tomorrow.
Cool.
Yeah, and don't forget to tune in because
What are we
have
doing
another
tomorrow?
day tomorrow.
Oh yes,
Final
Yeah.
day of IoT Design
Yes.
Week.
that is true.
Low
Sorry,
power.
Low
missed that
power,
one.
Power
Right.
sensor networks.
Sensor networks.
And do you guys
Everybody's
know-
talking about low power. Let's see what
Low
Mark
power.
Oh, yeah.
has to say about low power.
And so in addition to the amazing content, we'll also be giving away 2 of the highest dollar value prizes and 2 of the most exciting prizes, a ticket to Sensors Expo and a ticket to Embedded Technologies Expo and the conference associated with that. So make sure to tune in, fill out the survey if you're interested in that. And then one last note of programming, we will be postponing the afternoon live stream today to a future date. We'll do our best to make that happen. But thank you very much for your understanding.
Yeah, thanks. No, there was no electrical fires involved with that delay. It was just some tactical stuff. But I promise, I got some really cool rapid prototyping stuff to show you.
Yeah.
And
You guys gonna
it's
get
just
more
gonna-
Bobs in the future.
Right.
Don't worry about
Yeah,
it.
yeah.
The wizard will return.
The wizard, yeah, the
I
wizard
like
will
that.
return.
The wizard will return.
I like it.
Alrighty, guys.
right.
We'll see you tomorrow. It was very good. Bye.
All right.
Elbow bump.
All right, bye, everybody.